morning, dear students. Welcome back to today's session. And this session, we are going to discuss the second most important statistical tool of central tendency. In measures of central tendency, we have several statistical tools. In that, mainly there are three we are going to discuss in the chapter. What are that? Arithmetic mean, median, and mode. In previous sessions, already we have came to know about arithmetic mean, and this session we are going to discuss in detail about the median. Here, median is nothing but it's one of the main tools in order to find out the average, and your median refers to the exact middle value or middle element when data is arranged in order of magnitude. Data is arranged in order of magnitude. Magnitude means when data is arranged based on size, based on the importance, and based on the necessity. When we arrange the data in a particular order, in that order of data, the exact middle value or the central value or element will be considered as a median value. Got it now? Take a meaning. Median refers to middle value or element when data is arranged in order of magnitude, or then the data is going to arrange in order of ascending or descending, or based on importance or based on size. When data is arranged, then the exact middle element of that data will be called as a median. Okay, here the median is a positional value. Yes, in arithmetic mean it is affected by the extreme values, but here the median is the positional value. They can ask for one mark, which is a positional value. Okay, median is a positional value. Median is the positional, and it means based on the position of the value we are going to decide the median. Got it? That's why median is called as a positional value. Positional value of the variable which divides the distribution into two equal parts. And it is not affected by extreme item. Okay, this is what the median. Your median means it is the exact middle value or element when data is arranged in order of magnitude. Data is arranged in order of magnitude, or data is arranged in a ascending or descending order, or based on importance, or based on the size, then the middle value will be considered as the median. And here the median we will be going to calculate the based on position of a values. The position of a values. That's why we will call median as a positional value, because median we will be going to calculate based on the position of a data. That's why the median is called as positional value, and this positional value or the median value will be going to classify the variable or data into two equal parts, where we take central element as a median, then it will break the variables into two parts. Okay, below and upper parts. Got it? That's why median is the positional value. It divides the data into two equal parts, and here it won't be affected by extreme value. Means here we will consider only the position of the data or position of the values, not the extreme or lowest values. And that's why it won't be affected by an extreme number or extreme item. Got it? Extreme value or extreme item. This is what the meaning of a median, and here the median will be denoted through one particular sign, that is x lambda. Median is denoted through x lambda. Got it? And first we are going to discuss how to calculate median when the data is in individual series. We all know that data is in two form. Already we have discussed in the arithmetic mean. Data is in two form. One is grouped and another one is ungrouped. Grouped data and ungrouped data. In ungrouped data mainly there is one type, that is individual series data. And in group data there are two. One is discrete series and continuous series. Here the formula in order to find out the position of a median, we use some particular formula, but the formulas will be going to change for the individual series and discrete series and in the continuous series. That's why here we are going to start firstly how to calculate the median when data is in ungrouped form. It means individual series. Got it? Calculation of median for ungrouped data. Take first example question number 1. Take data. In order to calculate the position of median value, we can use the following formula when data is in ungrouped. The formula is x lambda. It means median is equal to the size of n plus 1 divided by tooth item. Formula is, in order to find out the position of a median, when the data is in ungrouped form, the formula is x lambda. It means median is equal to size of n plus 1 divided by tooth item. Your simple. N means number of items. N means number of items plus 1 divided by 2 we get. If we do, then we will get particular item. Okay, that particular item will be the position of a median. That particular item will be the position of a median. Got it? First we need to find out the size of an item, and after finding the size we can able to get the median value. Got it? Now the median we will be find out to the size of n plus 1 divided by 2 item. Got it? And now we go to the discussion of one particular problem relating to a ungrouped data. Take example question now. Question is data set. They have given 5, 7, 6, 1, 8, 10, 12, 4 and 3. This is what the data set they have given. How to calculate now the median we are going to discuss. But whatever the data they will give, you already understood the meaning, right? Median is the exact middle value of the data when it's arranged in a magnitude order, in order of magnitude. It means whether in ascending or in a descending order, we should be arrange the data. Whether if they have given in the data itself, they have given in any order, we don't need to make it proper order. If they are not given in any order, first what we should do, we should be arrange the data in any one particular order. It may be based on size, or it may be based on importance, or in ascending or in a descending order. Now we'll arrange the data in order of ascending. It means based on size. First small one, later bigger like that. Okay. Now we are going to arrange it. Take example x values. Which is the smallest one here? 1. Next 3. Next 4. Next 5. 6. 7. 8. 10. Next 12. Right? This. Yeah. Now we have given one particular order. Yes, right? Based on size, we have ascended the data. Now, after making an arrangement of a data, then directly we can apply to the formula. First, before going to apply to the formula, we need to find out n. N means number of items. Keep in your mind, your n refers to number of items in the observation. And directly we are not going to finding the median value, just we are going to finding the size of the median value, and after finding the size, then we will find out the median value. Now come here, we have arranged the data and we are going to apply to a formula, that is x lambda is equal to size of n plus 1 by tooth item. Here x lambda is equal to size of n 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? There are 9 items. N is 9. Right? N is 9. N means number of items in the observation or in the data. Your 9 plus 1. In place of n, we have written 9 plus 1 divided by 2 item. Got it? Then, now follow how to simplify it. Size of n plus 1. N plus 1 means 10 divided by 2. Divided by 2 item. And this is known as and next x bar is equal to size of 10 divided by 2. Fifth item will be the median. Fifth item will be the median. Fifth is not the answer. Fifth item is the median value. Fifth item is the median value. Now, which is the fifth item here? 1, 2, 3, 4, 5. Fifth item is 6. Then 6 is the answer. Then median. Median equals to 6. Got it now? First, we are going to find out the size of an item, and in that size, which value will be there, that value or in that position, which value will be there, that value will be considered as a median. That's why median is called as a positional value, or it is an exact central value. See, which is a central value. Above we have 4 numbers and below we have 4 numbers. Yes, right? This is a positional value. It's going to be divide the entire distribution into 2 equal parts. Above 4 and below 4. Yes, likewise. That's why it's called as a median or middle value, or it's a positional value. Got it now? Next, we'll discuss one more problem or one more example question. I hope all of you understood, right? When data is in ungrouped form, we have a formula that is x lambda. It means median equals to size of n plus 1 divided by 2 item. And before going to apply the data into this particular formula, first the data should be arranged in order of magnitude. It means whether in ascending or in a descending order, we should be arrange the data. After arranging the data, we should apply to a formula. Here in the formula, there is one value, that is n. N means number of items. N means number of items. Then, understood, right? Now we'll discuss one more problem relating to individual series. Now take out, calculate problem, calculate or compute in the sense calculate or find out, compute the median value in the data given below. Now take a data. 79, 89, 29, 41, 59, 64, 71, 78. Okay, this is what the data they have given. For this particular data, now we have to calculate the median value or middle element. Fine, got it? in an order. Now we are going to arrange this data in an ascending order based on the size. Come for the ascending order. Now I will give a x for the data. Which is the lowest value in the data? I will think 29 is the lowest value. Write down 29. Next 41. Then after the 41, I think 59. Next 64. Next 71. 78. Next 79. Then 89. Yes, right. Then find out n. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 items in the observation. Then n will be 8. Got it now? Then we'll apply to our formula. X lambda equals to size of, it means median equals to size of n plus 1 divided by 2 item. Next, x lambda is equal to size of, in place of n what we should return? We should write 8. 8 plus 1 divided by 2 item. Now x lambda is equal to size of 8 plus 1, 9. 9 divided by 2 will get 4.5. 4.5 item is a median. See now, it's our little bit confusion. Here we have 8 items for observation. Now the answer is 4.5. 4.5 means whether we should consider 64 or 71 as a median. 4.5 means in between this, right? 4.5 means 4th item as well as 5th item. In this condition, when 0.5, 4.5 or 5.5 or 6.5 like this comes, then we have to take in between these two values, we have to take the mean number. Mean numbers means the exact center number in between this. The formula is, okay. Median is equal to, the formula is 4.5, right? Then 4.5 means 4th item plus 5th item divided by 2. 4th item plus 5th item divided by 2 we should do. Then x lambda is equal to, what is the 4th item? 64. Then what is the 5th item? 71 and divided by 2. 64 plus 71, how much? 135 divided by 2. 135 divided by 2, the answer will be 67.5, right? 67.5. Then the median value. Now it's not a 4th item as well as 5th item. Now we have exactly find it the mean item between these two numbers. The mean number or the median number or median value is 67. You can write here. X lambda is equal to 67.5. Got it? The 67.5 comes here. Then this value will is a positional value and it divides the data into two equal parts. Got it now? This is how to calculate median when data is in individual series or ungrouped form. Now we will move to discussion of median when data is in grouped format, that too especially when data is in discrete form. Discrete One is observation and another one is frequency. When there are two columns, it means when the data is in discrete form, how to calculate the median value, that will be discussed now. I hope understood, right? When 4.5th item, your value is not finded. 4.5 item is, we can't consider even 4th item or 5th item. Then we need to find out the in between this. Then the formula is when 4.5 comes, 4th item plus 5th item divided by 2 we should do. Or else 5.5 comes means when formula is 5th item plus 6th item divided by 2. Or if 8.5 comes, then the formula will be 8th item plus 9th item divided by 2. Likewise, okay? Keep in your mind. When calculation of median for grouped data, that is especially in discrete series. Okay. Now the same formula we will apply for the discrete series, but in discrete series we will be having frequencies column as well as observation column. There will be two columns. In that, what we will do the cumulative frequency. Based on the frequencies, we will take up cumulative frequency. Cumulation means adding of the frequencies based on less than method. Based on less than method, we will be going to add the frequency one by one. That is called cumulative frequencies. We will find out the cumulative frequency, and based on the cumulative frequencies position, we will find out the median value. In case of discrete series, the position of median is located through can be located through cumulative frequency. And next, one more important, the corresponding value at this position is the value of median. Got it? Here, when data is in discrete form, while calculating the median, the position of median can be located through cumulative frequency. Here, cumulative frequency means the frequencies we will be add one by one through less than method, and based on the position, the correspondence value of that cumulative frequency will be considered as a median. The corresponding value of this position, we will find out the position through the cumulative frequency, and the corresponding value of that position will be the median. First, we will find out the position through cumulative frequency, and the corresponding value of that position will be the median. Got it now? Now we are going to calculate one particular problem under this. Okay? Take out the problem now. Here, take down example question. One, the frequency distribution of the number of number of persons and their income or given below. Calculate median income. The data is income in rupees. Next, number of persons. For this, we'll give as a F. Here, income is 10, 20, 30, 40, and persons is 2, 4, 10, and 4. This is what the data they have given you, and for this particular data, here they are given frequency distribution of the number of persons and their income, and for this we need to find out the median. In this question, what we do, when the data is in discrete form, first we need to make cumulative frequency. Take after this two column, take one more column, cumulative frequency, or in shortcut we can use CF. Cumulative frequency means adding of the frequency one by one based on the less than method. Okay, or more than method. Okay, when the income is 10, there are 2 workers. When income is less than 20, there are 4 plus 2, 6. When income is less than 30, 2 plus 4 plus 10, 16. When income is less than 40, then this all will comes for less than 40, right? Less than 40 means 16 plus 4, 20. This is what cumulative frequency. Cumulative frequencies we will do, that means we will add the frequency based on less than method. Less than 10, 2. Less than 20, 4 plus 2, 6. Less than 30, 10, 4, whereas we have already added 6 here. 6 plus 10, 16. 16 plus 4, less than 40 means 16 plus 4, 20 we will get. After doing this cumulative frequency, we will find out the position of a median, and the position will be based on the correspondence value of the particular position will be considered as a median. How to find out the position means the formula is x lambda is equal to n plus 1. Size of n plus 1 divided by 2 items. The same formula will be going to continue, but one thing will be going to change. Your n means not a number of items. N means total number of frequencies. Keep in your mind, in individual series data, n means number of items. When in the discrete series, in the discrete series, n refers to total number of frequency. Total अथवा sum of frequency will be called as n. Here total number of frequencies or sum of frequencies will be 20. When we have cumulative frequency, we will get that, right? 20. Then x lambda equals to size of n means sum of frequencies. Sum of frequencies is 20. 20 plus 1 divided by 2. X lambda is equal to size of 21 divided by 2. We will get 10.5 item. 10.5 item will be the median. Now, it is not a value of a median, right? It's the position of a median. Then 10.5. Where it comes in a median values, in a cumulative frequency. What we did, we added the frequencies in less than method, right? In this 10.5, the value of 10.5 where it appears in 16, there will be a 10.5, right? In 16, there will be a 10.5. Then the corresponding value of the position will be considered as a median, which is the corresponding value of this position 30. 30 is the median income of the workers. Which is the median income of the workers? 30. Then x lambda is equal to 30. 30 now it's simple. After the entering the data, firstly we need to find out the cumulative frequency. And one thing you understood in the formula, here n refers to sum of the frequencies. Our total value of the frequency will be called as n. The total value of the frequency is 20. 20 plus 1, 21. By 2 if we do, we will get 10.5 as the answer. This 10.5 in which cumulative value it appears? In the value of 16 it appears. This corresponding value of this 16 will become the median. Got it? This is how to calculate the median when the data is in discrete form. I hope all of you understood how to calculate the median when data is in individual observation and discrete series. Thank you everyone. We'll meet in the next session.